Hi everyone. Hi second year students. It's Math with AUB. The new book of National Book Foundation hasn't yet been published, but somebody has shared 121 pages with me, and I have started my journey from integration. In order to look 100% different from all this, let's see and find out without wasting time. Jot down to these questions. If you have done differentiation, you have encountered three type of data. Three types of data. I used to call it base variable power constant, the normal case. Base variable power constant, the normal case. It is base constant power variable, entirely different from this one. And that is the third type of data that is present in our differentiation, base variable power variable. Base variable power variable. Mostly student grapple with only this situation, and he is blind to realities of these two, and they cause trouble problems while integrating, because in case of differentiation they have done through formula. Let's see and find out. Always keep these three facts in mind: base variable power case, power variable, base variable power constant, normal case, base constant power variable, something different. Such type of data are hardly present in integration. Let's see question number 1. X square minus 3x plus 9 times dx. This is known as simple integration. Simple integration means if we are in a position to multiply integral symbol and dx throughout, or after some calculation, it is simple integration. So it can be written as x square dx minus 3 times x dx plus 9 times dx. It is opposite of differentiation or antiderivative. Instead of dragging one down, instead of making the power coefficient, add 1 into the power, dividing with the same power. That is the reverse process of differentiation. How we differentiate? We make the power coefficient and subtract 1 from the power. We make the power coefficient and subtract 1 from the power. Making power coefficient means multiplying with the power, and subtracting 1. Look here, instead of multiplying, we are dividing. And we are enhancing 1. Similarly, this is the case. Add 1 into the power, dividing with the same. Here, really very easy one. Okay, let me give you a good idea. There is no variable. I can write x raised to 0, where obviously x is not equal to 0. Instead of 1, I can write x raised to 0. So it is also your simple integration. Just write in that fashion: 1 over 3x cube minus 3 over 2 x square plus 9, 0 plus 1, it's 1 over 1. That's integration constant c. That's our answer. That's our nothing new in that case. Take care of this thing. There's 9, there's no variable. I can manage the variable by giving you a good idea. X raised to 0 can be introduced, provided that x is not equal to 0, it's equal to 1. X0, enhance 1 into the power, add 1 into the power, divide with the same, in order to start your journey in integration. That is the way a constant can be integrated. Pure constant can be integrated in that fashion. Or normally you can write, ask yourself, what is this? There is 9, 1 dx. Ask yourself, one is differentiation of what? One is differentiation of x. So 9x is our result in that case. Either way, they give you good idea. Going towards question number 2, it's also simple integration because we are in a position to multiply integral symbol and dy throughout. What I have? Y square plus 8y root 2y times dy. Simple integration: y square dy plus 8 times y dy plus root 2 times dy. Simple. Add 1 into the power, divide with the same. Here, no variable. We can manage variable by y raised to 0. Integrate y cube dividing by 3, 8y square dividing by 2 plus root 2, 0 plus 1, 1 over 1, integration constancy. Applying table, we have 1 over 3 y cube plus 4y square plus root 2y plus c is our answer in that case. Simple one. Just I want to emphasize something on this. How to integrate constant, you should have fair idea about this. That is my advice to you. Emphasis on this fact. The rest, in case of simple integration, they are easy. Question number 3, we have root y plus 1 over y square. It is still simple integration. Root y means 1 over 2 dy. This one can be written in the numerator as y is minus 2 dy. Point to be noted, my lord. We add one subtract in case of function when function is in the numerator. Where function is in the numerator. There's two I have done. Furthermore, 1 over y, it is exception. We cannot one add into it. It's later to be discussed. My lord, whatever the power is, you can shuffle into numerator, change the power and get through. If power is 1, overall power 1 in denominator, is an exception. Don't add 1 into it. Okay, moving towards our question. By adding 1, we have y is 3 over 2, dividing with the same. Furthermore, adding 1, it will become minus 1 over minus 1 plus c. Double division, it can be written as 2 over 3 times y is 3 over 2, minus plus minus, converting y, power of y negative, from negative to positive, it is 1 over y plus c. That's our answer in that case. Simple integration. We add 1 after shifting the function in numerator. If function has overall power 1, if function has overall power 1 in denominator, or in numerator y raised minus 1, we cannot add 1 into it. It's our exception. Let's see and find out later how and why. Next, here is 4 plus x square whole square dx. It is simple integration, but we have a little bit calculation. Apply whole square formula, it will become 16. 2 times 4 times x square, 8x square. Square of x square is x4. Opening up the identity, a square twice ab plus b square. Now there is 16. 16 is a pure constant. Let me manage by x raised to 0 plus 8 x square dx plus x4 dx. Add 1 into the power, it will become 16 raised to x over 1. It can be 8x cube over 3, x raised to 5 over 5 plus c. Nothing has been cancelled out. It's our tiny answer. Simple integration. Look, part 2, 3, we are in a position to calculate. Attempting next question. It's also simple integration. Just multiply the two brackets, add 1 into the power, and we are going to get through 5. Nothing to worry about. It's 1 plus x times 1 minus x square dx. Multiply. It will become 1 minus x square plus x minus x cube dx. 1 the 1 minus x square. X times 1 x minus x cube. Simply multiplying integration symbol and dx, we have minus x square dx plus x dx minus x cube dx. Here is 1, it is pure constant, nothing. I can introduce x power 0, adding 1 into the power, adding 1 into the power, adding 1 into the power, adding 1 into the power plus c. It's our answer. Nothing we can do to simplify this further. Question number 6, also a simple one. We have done something like this in question number 3. Let's see question number 6. Root x plus 1 over 2 root x dx. Cool. Multiply integration symbol and dx throughout. Here there is 1 over 2. Power is not 1. Power is not 1. If 1 over x is the case, then I cannot shift this in denominator and I cannot add 1 into it. That is the exception. That is the exception. It is power not 1. I can shift into numerator from 1 over 2 to negative 1 over 2, from denominator to numerator. Enhance 1 in the power, add 1 into the power, it will become 3 over 2, 3 over 2, 1 over 2. By adding 1, it will become positive 1 over 2, 1 over 2, 2 cancelled out, plus c, double division, 2 over 3, raised x over 3, plus root x raised 1 over 2 can be written as root x plus c. It's my tiny answer in that case. Question number, I think 7 it is. 7, it's also simple integration, but from now on we are about to encounter such type of data where base constant power variable is present, base constant power variable. Second, if overall power is 1, these two things we have to negotiate like an expert navigator. We have to navigate in style. When base constant power variable and function is in denominator having overall power 1, having overall power 1. Let's see and find out question number 7. I have e raised 4x, e raised minus 1 plus 1 dx. Look at this, e raised 4x, e raised 4x, base constant power variable. It is not the case I add 1 into the power and dividing with the same. Dividing with the same. This is not the case. This is not the case. Okay, let's refresh in our memory how to differentiate such type of questions. Derivative of e raised 4x with respect to x. I used to call it base constant power variable. Base constant power variable. Base constant power variable. It will give you confidence, something clarity. You should follow this. How to differentiate this? Write this same e raised 4x same. Then differentiate the power. Differentiation of 4x means 4 times 1 and base with ln. Base with ln. Ln e. We are familiar, ln e is 1, e raised 4x into 4 into 1. So we have 4 times e raised 4x. 4 times e raised 4x. That is the way of differentiating a function when base is constant, power is variable. When base is constant, power variable. Right, same differentiation of power, base with ln. Same differentiation of power, base with ln. In case of integration, we have to divide with these two quantities. These two quantities goes in the denominator. Differentiation of power as well as ln with base. Differentiation of power, ln with base, they go to denominator. Let's see and find out. Base constant, power variable. The game changes, the story changes. Here we cannot add 1. Just multiply simply throughout e raised 4 dx minus e raised minus 1 dx plus 1 raised dx. Base constant power variable. It's same. Divide with the derivative of power as well as ln with base. Ln e. We are familiar. Ln e is 1, 4 1 the 4. Here e raised minus 1. There is no variable I can write x raised 0 dx. Here there is no variable x raised 0 dx. I can manage x over 1 over 1, x over 1 over 1. That is the case. Ln e is 1. So I have 1 over 4, e raised 4x, e raised minus 1 times x plus c. That's my answer in that case. Here e raised minus 1 is a pure constant. E raised minus 1 is a pure constant. E raised minus 1 is a pure constant. Look at this. The story changes. The story changes. Base constant, power variable. Base constant, power variable. Its integration is right same. Divide with the differentiation of power, base with ln. Divide with the differentiation of power, base ln. In case of integration, when base is constant, power is variable. When base is constant, power is variable. When base is constant, power is variable. Okay, moving towards another question. Here comes 1 over x. Why cannot we shift x raised 1 over x to x raised minus 1 dx, and we could not add 1 into it. Why? Why? We are almost there. We are almost there. Question number 8. E raised 9 over 2x plus 1 over x dx. It is our base constant or variable situation. Here x having power 1. Let me write for you in words in order to emphasize the situation, clarify the situation. X is in the denominator, having power 1, having power 1. How to handle this? You are familiar. I have already told you. Write same. E raised 9 over 2x. Divide with the differentiation of power. Differentiation of power 9 over 2x means 9 over 2 times 1. Introduce e with ln. Ln e. Right, say base constant power variable, base constant power variable, base constant power variable, right, same, divide with the differentiation of power, introduce e with ln, introduce e with ln e. Here we are about to discuss why we cannot shift x raised to minus 1 and we cannot add 1. Why? Simple fact is that, just have a look at what is the differentiation of ln x. What is differentiation of ln x? Differentiation of ln x is 1 over x. Differentiation of ln x is 1 over x. Taking integration both sides, derivative integration cancel. We have ln x as the integration of 1 over x dx. So, while integrating, we ask ourselves, is it derivative of some function? Yes, it is differentiation of ln, it is differentiation of ln. So, its integration must be ln x, must be ln x. We cannot add 1 into it. It's our exception, it's our ln case, it's our ln case, it's our ln case. So, we have double denominator can be written as 2 over 9. E raised 9 over 2x, and it is our famous log modulus. 1 over x is the differentiation of ln x. 1 over x is the differentiation of ln x. 1 over x is the differentiation of ln x. Its integration is ln x, ln x. Let me write once for you a formula for this to be kept in mind. Later, or more than 70% integration depends upon what do you mean by a function and its derivative. How to find function and derivative? If differentiation is present in the denominator and function is in the denominator, derivative is in the numerator, function is in the numerator, having overall power 1. Let me write ONE1 in block letters. Function derivative, and function is in the denominator having overall power 1. Function is in the denominator having overall power 1. I have written ONE1 to strike you, to have a look at this, take care of this. Its exception, its integration is ln the function in the denominator, ln the function in the denominator plus c. Ln is the function in the denominator is the case in that case. Check our situation, 1 over x dx. Now look, if it is our function, what is differentiation of x? It's 1. Function derivative, having overall power 1, having overall power, it is the case of ln, it is the case of ln, it is the case of ln, it is the case of ln. I hope you keep a note of this one as a special one. Moving further, the rest is really very easy. After 9, here comes 8. Here comes, after 8 there's 9. X raised e x square dx, x raised e, x times e raised x square dx. If 2 is not present here, it is the case of by parts. Sorry, I don't want to indulge here and there. Just check function derivative. After simple integration, always check function and derivative, whether substitution prevails or not. Function derivative with a little bit deficiency of a constant or a symbol we can manage by dividing and multiplying. Deficiency of constant can be compensated by dividing and multiplying. Okay, check. If I take x square as function, x square as function, its differentiation is 2x. Its differentiation is 2x. Its differentiation is 2x. Only 2 is missing. Only 2 is missing. If I write in that fashion, 1 over 2 e raised x square times 2x dx. Now look at this. This is our function, this is our derivative. This is our function, this is our derivative. Let me write a general form of this one. E raised function and its derivative. E raised function, e raised function and its derivative. E raised function and its derivative. E raised function and its derivative. Its integration is given by e raised f of x plus c. E raised f of x plus c. What is our f of x? What is function? It is x square. 1 over 2 e raised x square plus c is our answer in that case. There is another good form of integration questions. E raised function times its derivative is equal to e raised function only. E raised function. E raised function. From where comes or occurs, just simply differentiate e raised f of x. Differentiate e raised f of x and you are going to have same result as this. Let me verify for you. Look at this. 1 upon 2 x 2x e raised x square dx. Its integration is e raised x square. E raised x square. Okay, differentiate e raised x square. E raised x square. Write it same. Multiplying. What is the power of? What is the differentiation of power? Differentiation of x square is 2x. Differentiation of x square is 2x. Here 1 upon 2 is also present in our cancel. We have same e raised x square dx. E raised x square dx. E raised x square dx. Look at this. 1 over 2 e raised x square. Base constant, power variable. Base constant, power variable. Right, same. Differentiation of power. ln with base. ln is 1. 2 cancel out. We have ex square x dx. We have e raised x square dx means its integration is definitely this quantity. Or for to prove formula, it's really very easy as well. I have written e raised function and its derivative integration is only e raised function a sum constant. Taking a sum constant and differentiating this one, e raised f of x plus c. Differentiate. Same, because it is our base constant power variable. Same differentiation of power, it will become f dash x. Base with ln e. Differentiation of a constant is 0. So we have e raised f of x times f dash x. So differentiation of this one must be this. In order to find it is the derivative of which function, it is the derivative of which function we have to integrate, and here is the net result for this one. E raised function times derivative. E raised function times derivative. Its integration is given by e raised function. E raised function. E raised function. E raised function. Okay, cool. 5 and 7 we have already done. Base constant power variable type situations, and we are about to wind up. 10. Question number 10. 5 raised x dx. It is base constant power variable. Right, same. Divide with the differentiation of power base with ln 5. So ln 5 does not equal to 1. It's our answer in that case. What about 11? 7 raised 7y dy. Same. Base constant power variable. Base constant power variable. Right, same. Divide with the differentiation of power. 7 times y means 7. Base with ln 7. We have 7 raised 7y divided by 7 times ln 7. It's our answer. It's our answer in that case. It's our answer in that case. Let's see question number 12. Let's see question number 12. It is simple one. We have done all these questions, all these cases. Let me give you a good refresher. X cube plus 1 over 2x minus 1 over x cube dx. Inspect the situation. Simple integration. 1 over x is the differentiation of ln x, its integration ln x, and in that case we shift x cube to x raised minus 3 and add 1. Simple integration. X raised cube dx 1 over 2. Its exception, its ln case, it can be written as x raised minus 3 dx. Add 1 into the power, add 1 into the power. Here, it is case of ln, it is case of function derivative having overall power 1. Function derivative, having overall power 1. It's case of ln x or ln mod x. It will become minus minus plus. So we have eventual answer 1 over 4 x4, 1 over 2 times ln x minus minus plus 1 over 2 x raised minus 2 plus c. You can shift this one into numerator to make it positive or leave here. It's up to you. Or one can make the coefficient of log as power. 12, now 13. 13 one. We have 2x plus 1 overall x square plus 3 dx. A good question to negotiate. Having overall power 1, differentiation of x square is 2x, and differentiation of 3 is 0. 3 is 0. We have 1. We have 1. If there is no 1, it is only case of ln. It is only case of ln. But here, additional 1 is present. Simply, being a mathematician, being good at maths, divide denominator separately. We have 1 times dx overall x square plus 3. Now look at this function having overall power. Let me write in capital O anyone in order to emphasize, in order to highlight, in order to captivate the situation. X square plus 3 overall 1. Differentiation of x square is 2x dx. Function derivative, overall power 1, overall ln function is our answer. Ln function is our answer in that case. Look here. Look here. You are familiar what is the differentiation of tan inverse x? What is differentiation of tan inverse x? That is 1 upon 1 plus x square, and differentiation of tan inverse of x over a differentiation. It is given by 1 over a, 1 over a over a square plus x square. So we have this situation, and its integration must be this. There is also a second possibility by magic substitution. I am managing both for you. I can write this as x square plus root 3 square. Now that is my case. That's our x, that's our a. That's our x, that's our a. That's our x, that's our a. Our x is x, a is root 3. Instead of its integration is given by 1 over a tan inverse of x over a plus c. Here x is x and a is root 3. So we have 1 root 3 tan inverse of x root 3 plus c. This one same. Ln times x square plus 3 as it is. Ln times x square plus 3 as it is. That's our answer. To me, this is the good question from your whole exercise. This is the good question from your whole exercise. Question number 7 cannot be ignored. Question number 14 cannot be ignored. Question number 16 cannot be ignored, because they are paving way for further understanding. If you have good understanding of this one, then you are in a position to hunt in next exercise as well. Otherwise, you are going to roam in this exercise again and again. Okay, I can also give you the idea of magic substitution to prove this formula as well. Then I am proceeding towards 15, 16 and so on. What I have, this is the case again. So to solve for this, 2x plus 1 overall x square plus 3 dx. What we have done, 2x over x square plus 3 dx and 1 over dx dividing by x square plus 3. Here it's our function and derivative. It's case of ln x square plus 3 once for all. What about this? In that case, we have to write in standard form x square. There should be a square. 3 is there, root 3 square. In that magic, so for this magic substitution is x square plus a square. Always use magic substitution. X is equal to a tan theta. x is equal to a means root 3 tan theta. Suppose differentiating dx over d theta is equal to root 3 times sec square theta. Shift d theta over there. Differential dx is root 3 times sec square theta d theta. Value number 1, 2, it's value number 1. Put both these values in this integral and you are going to arrive at some result. You are going to arrive at, let me check the angle. A step also I can write. So let me erase this in order to be in a frame. Put here 1 means root 3 1 over x square plus 3 square dx is equal to, instead of dx I have written root 3 times sec square theta d theta. Instead of x I can write root 3 square tan square plus root 3 square. Root 3 square common from the denominator. I have root 3 sec square theta d theta. Root 3 square common. What remains? Tan square plus 1. Cancelled out. 1 root 3 remains in denominator. Tan square plus 1 is equal to sec square theta cancelled out. We have suppose in that case x is equal to root 3 tan theta. It will facilitate our work when we substitute. What remains? 1 over root d theta. It can be written as same strategy. I can write 3 raised to 0 d theta where theta is not equal to 0. Add 1 into the power 1 over 3 theta over 1 divided by 1 plus c. How to find value of theta? We have started our function. Our variable is x. Now we are wandering in d theta. Reput the value from theta here. Shift 3 here. It will become x over root 3 tan theta. In order to shift 10, take tan inverse both sides. Or shift 10 here. It will become tan inverse or arc 10. Tan inverse x over 3 is equal to theta. So we have 1 over root 3 tan inverse of x over root 3 plus c. That is the magic substitution when we apply in upcoming exercises x square plus a square. The supposition is x is equal to a tan theta. Supposition is x is equal to a tan theta. Question number 13 to me, Shama Mafil. Moving on. Question number 14 is also a good one. It is linked with this one. Function lies on the power of e. Here, it's our function. It's in the same token. Tan inverse z is equal to 1 over 1 plus z square. It is present over here. Let me open up this situation. Can I change my mark? Why not? E raised tan inverse z over 1 plus z squared. Famous, notorious question. Present everywhere. Function derivative works wonder. Here, e raised tan inverse z. I can write this as 1 over 1 plus z squared dz. Now, what is differentiation of tan inverse z? Let me write for you. You are familiar with respect to z. It is 1 over 1 plus z square. It's our function. It's our derivative. Function lies on the power of e. Suppose it is e raised x and it's our dx. Function derivative. Suppose it is x, it is its differentiation dx. So integration of ex is only ex. We put the value. We have e tan raised z plus c. Tan raised z plus c. Or one can adopt orthodox method by suppose z is equal x is equal tan inverse z. Differentiating with respect z dx over dz. We have 1 over 1 plus z square. Shuffle the differential dz over there. We have dx is equal to 1 over 1 plus z square times dz. Putting these two values in here, we have substituted like this. It's equal to e raised x, and instead of this one, I have written dx. It's our e raised x, it's our dx. So its integration is only e raised x plus c. What is the value of x? That's tan inverse of z. Tan inverse of z. Function derivative. Function derivative. This is the tiny tick that we have adopted. E raised function times its derivative. Dx is e raised function is the integration of this entire culture. Moving towards 15 question 15, one is the simple one for to me. Question number 17 is also simple to me, and I have also solved these in my first frame. Let me embark upon 16 and 18 for you. I have done these two questions in frame 1 as well for you. I have started frame 1 from retrospective fashion. Now I have coming down from up to down, in letter case from bottom to top. Question number 16, a good one, base making function derivative situation. 3x square plus 2x, it is x cube plus x square plus 9 dx overall 5. There is no need to multiply 5 times, then multiply with this bracket and then add 1. Simply ask yourself, this is the bigger function having good power, greater power than this. What is differentiation of x cube? 3x square. What is differentiation of x square? 2x. Bingo. Function derivative. Function derivative. Just simplify the situation. X cube. Arrange the situation. X cube plus x square plus 9. There is 5. That's our 3x square plus 2x dx. To me, this trick is very near dear to me. Function and its derivative. Function derivative. Function derivative. Function derivative. Function derivative. Function derivative. Add 1 into the power of function and its answer. X cube plus x square plus 9 raised 6 divided by 6 plus c, it's our answer. If you conclude this session, what we have done? E raised function and its derivative, its integration is e raised function plus c. What is vital? Function derivative, function derivative, function derivative. What we have done in case of 1 over x dx, let me write its general form. General form, there is derivative in the numerator, denominator, having function overall power 1. Look at this. Look at this. The strategy, the technique, function derivative works wonder. Function derivative, function derivative, function derivative, function derivative, overall power 1. In this case of ln function, ln r function plus c. Here it's a normal case. Function derivative. And third one is function raised any power times derivative. Okay, let me be in frame. Let me be in frame. I try my best. And the third one is function raised to any power. This is the derivative dx. That's why in such type of question there is a restriction. M does not equal to minus 1. M does not equal to minus. If m is equal to minus 1, then it is the situation of ln. It is situation of ln. M does not equal to minus 1. M does not equal to minus 1 is an exception. Why? Because m is minus 1, then that is the case, that is the integration. If m does not equal to minus 1, then its integration is given by add 1 into the power dividing with same, add 1 into the power dividing with same, and 1 into the power dividing with the same. And it's cool, we have done. Let's, okay, to you solve, let me solve 18 as well. 18, I have left a question also, but in frame 1 I have done all. 18 and final question, there's minus 1 over 4 dz plus root 3z dz. One step further, I multiplied this integral symbol and dz with everyone. E raised 1 over e raised z dz. Simple. Add 1 into the power, it will become 3 over 4 dividing with the c. In next step, it will become 4 over 3, z raised 3 over 4. What about this? This is root 3, z raised 1 over 2. Add 1 into the power, it will become root 3, add 1, it will become 3. 1 upon 2 plus 1, it will become 3 upon 2. In latter case, 2 will be there. Plus 4 outside, 1 over z dz, 1 over z dz. Look at this. Function derivative having overall power 1, overall power 1. Its exception is 4 ln z. And in that case, we have to shift e raised to minus z. We have to shift ez to numerator, e raised minus z. Its integration by the same method. Let me write 4 upon 3 z raised 3 over 4 plus 2 times root 3 over 3 z raised 3 over 2 plus 4 times L and Z. It is same base function, base constant, power variable, base constant, power variable, right? Same. Divided with the derivative of power, it will become minus 1. E with ln, ln e is equal to 1, and it will become negative, negative, positive. Writing all same, 4 over 3, z raised 3 over 4 plus 2 times root 3 divided by 3, z raised 3 over 2 plus 4 times ln z minus minus plus ln e is 1, e raised minus z plus c. It's our answer, or one can write this 1 over ez, 1 over ez. It's my tiny effort to you guys to explain to you exercise 3.1. Mark my words. Function derivative works wonder for you. Just function changes the position. Function sometimes present as power of e, power of a constant, or function might be in the denominator having overall power 1. Function might be in the denominator having power not 1. Function might be in the numerator having whatever the power is. Just hunt function and derivative, hunt function and derivative like a hunter, then pull the trigger, and you are going to get at least one prey. It's all by itself. Next.